The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
Mitsubishi.
All right.
We are in Miami at the 2023 Diamond Contractor Summit.
Yes. Actually, it's a conference.
And we found a little quiet time. Everybody's out
Well, the bar's open.
the
the
bar's open. Everybody's
place
having-
emptied out really quick.
Yes.
Except for us.
They're in line at the
teetotalers.
bar.
There was no alcohol in here. I just want everyone to know that.
Yeah.
I like to just say thank you. Thank you very much.
And when I'm in Miami, I think about Cubanos.
Cubanos.
Sí, señor. Yo soy cubano.
Is it Cubanos or Cubanos?
Cubanos.
Cubanos.
Yeah.
Like Cuba.
Cubanos. And,
You need those because it rains a lot here.
So tell us a little bit about yourself, Juan. And
Isn't this home for you, Juan? Miami?
Yes. Actually, this was my first American city that I landed on from Cuba back in 1971.
71 when you were, what, 37 back then?
I was 12 years old.
12 years old.
So if you do
Life's
the math.
been rough for you, I think.
Yes, actually, it's been good to me.
Yeah.
The corruption
But
started
yes,
here in the north.
we came into the Miami International Airport, and I'll never forget. I have pictures of me standing at the fence before we were processed, before we were allowed into American land.
That's amazing. Well, I, for one, all kidding aside, am glad you're here.
I am,
But we're in Miami, and like Steve, I also think of Cubanos every time.
Yes.
Is it now, for officially, is it Cubano or Cubano?
Cubanos.
Cubano. So have you ever heard of a movie called Chef?
As a matter of fact, I have.
Yeah. So they came out in 2014. I think Jon Favreau was in it. He wrote it. Sofia Vergara, Scarlett Johansson. Yeah. Okay. Anyway, it's all about this guy who gets a food truck and starts making these Cubanos. Right. And I looked up the recipe, right? And it calls out, you tell me where this is wrong if it's not
Okay.
authentic. It's 2 thin slices of baked leg ham,
Yep.
4 large thin slices of mojo marinated pork, 2 pieces of white baguettes. Well, we'll talk about the bread later because I know you got something to say about that. And you got some brushed on melted butter. You got some mustard. It says here
mustard.
American mustard, but I like the spicy mustard,
I
the brown
love the
mustard,
spicy
deli
mustard.
mustard, I think they call it. 2 thin slices of Swiss cheese and 2 or 3 dill pickles.
Yes. And in some cases, we've added turkey slices to it also.
So ham,
Pork and
pork,
turkey.
and turkey. Well,
Yes.
so
technically.
talk about the pork, because that's
The pork is a long process. It's the longest thing. Is we marinate it overnight, at least 24 hours, with garlic and lime and citrus. And
you sent me
let it-
that recipe once, and I
Yes.
tried it. It was delicious.
And it's very tasty. And that meat absorbs that marinade.
and the meat actually turns white because
Yes.
of all the acid. And
Yeah.
and
Exactly.
yeah.
It tenderizes.
Exactly.
It tenderizes it,
Yes.
so it just falls apart.
So you
melts in your
bake it.
mouth.
You bake it, and you can have it either shredded or sliced. Some people like it shredded, but it's delicious. No added salt, no added anything.
So how long are we marinating? For
24 hours.
24 hours. And you want to make sure you flip the meat halfway through. That's
after
important.
12 hours.
Yeah, I did mine. I marinated it for over 24 hours. I got to tell you, it was probably some of the most tender meat I've ever had.
Yeah, and you want to not stab the meat so the garlic and the marinade goes internally into the meat.
Right.
So it can
It seeps
marinate
in
from
there.
within.
All right. So we'll talk about the bread later. But
Okay.
let me know where I'm going wrong here. Right. Now, this is according to some website. It's specifically from the movie. You got to use a skillet. I think it's a cast iron skillet. I don't think there's any other skillet you should cook this on. You heat the skillet over medium heat. You add the ham and the pork slices. You cook each side until they're nice and brown. You remove that and you butter the cut side of the breads, like the baguettes or whatever bread we're going to use. And you put those in there until they're lightly browned, a couple of minutes, right? And then you layer the bottom of the baguette with pork, with the ham and the cheese, and then the pickles. And you cut it, and you fold the ham and the pork and the cheese so they fit. and you spread the cut side bun tops with mustard, and then place it on the sandwich. You know, and then you butter the bottom and the top on the outside of the baguette. You heat the skillet again, and you just throw those baguettes in the skillet, and and you top it with some parchment paper, and then you just go to town. But you gotta let the sandwich sit a little while.
You do.
Well, don't we have to use a press?
Well, and but the way that he's prescribing was relative to the movie. Some people have used a skillet, but the way I've always done it, it's been with a sandwich press.
Yeah.
And I actually put the butter on the outside of the bread.
Right.
And then I put all the ingredients in, put the other half of the bread on top, and then I press it until it's almost flat, because the Cuban bread is very airy because we use lard to bake it with, and then it's just delicious because when you press it, it gets really toasty without burning it.
And if I don't have a press, though, I could use another heavy cast iron skillet
Just
and
to
just
press
put it right
yes.
on there. Oh,
Yep.
Okay.
Yeah.
If I hadn't just eaten, I'd be hungry.
It's a great sandwich, easy to make.
That sounds amazing.
Yeah. Once you get the pork done, that's the hard part.
The hard part is finding the pork.
Now, if there was a side to throw in with a Cubano,
There is plantains. There's tostones, which is the green plantain flattened and deep fried.
yeah,
Or you could let it ripen, and it'll turn. The darker the plantain turns, you would think it's rotten, but it's not. It's just getting sweeter.
Right.
And then you slice it into sweet plantains, and that's a great side.
So, what's the difference then between a Cubano and like a panini? Because I have a
The
panini
difference
maker.
is the bread.
It's just the bread.
Just the bread.
Because a Cubano, I suppose you could put any meat, anything you wanted inside the sandwich.
You could, but the original is pork, ham, and turkey.
Okay.
all right.
I like that. Going around the farm.
That's amazing. Welcome to the METUS Tech Show, everyone. And I just want to point out that we just recently celebrated our 1-year anniversary of the METUS Tech Show.
Yeah.
Happy birthday to you!
First episode, everything training,
We got at least 7 listeners.
November 3rd was
At
released.
least 7.
At least 7 listeners.
That's great.
What's that?
I think we have at least 7 listeners.
7. Come on now. We got a lot more than 7 listeners.
Thousands.
Yeah, we're growing. We're growing.
Very much so.
We'll take a baby steps, but we're growing.
And grateful for those that are downloading the podcast.
Yes,
listening.
absolutely. We love our listeners, and
And
we
keep
hope.
sending ideas.
I just hope, in all seriousness, I hope the people who listen to us enjoy listening half as much as we enjoy putting these together. Because speaking for myself, and I think for you guys too, these are really a lot of fun. to
Yes,
do.
absolutely.
Yeah, we started off with
Sometimes too much fun.
Yeah. Well, that's why we edit these and we don't do live.
And people, not all of them make it out to the public.
No, some of the comments, would be
Well,
a
it's
little
not just
goofy.
the con. Sometimes the laughter.
Yeah.
Oh, sometimes they just flat out get deleted.
Yeah, there we go again. I can't live that down.
Yeah, Paul just hit the button the wrong period of time. Wrong
we
sequence.
had probably a perfect podcast that was going. There was no mistakes, no edits.
Subcool and super heats.
Yeah, and then I hit the button to just pause, and it turned out I deleted the whole thing. And we'd worked on it for like a half hour, and
It was perfect.
Yeah.
That was a bad
it was
day
one
for
of Brent's
Steve.
first one.
yeah, Brent's first one. He did good.
He was all nervous, did great. And then Steve walked in the room, and Paul looked at Steve, big puppy eyes. He goes, "Wait until you hear this one." And then
There
where is
was
it?
nothing.
And then it's like, how long did you hit the button? And then it was just laughter.
Yeah, it happens.
Big puppy eyes.
This is why Steve's at the controls and not me.
Yeah.
Yeah.
So myself, Steve, and we got Juan Cardona
Yay.
from Ohio Training Center, and you all know Roland Wager from the Orlando Training Center.
You got it.
It's not too far for you, Orlando to Miami, right?
What's that?
4
Orlando
hours.
to Miami, not too far. You're in the same state. You drove down. What did it take you?
Almost 5 hours.
6 hours.
Oh, that's easy.
It's traffic. Well, I live north of Orlando.
If there was no
45.
traffic, how long would it have taken?
290 miles. So
4 hours.
yeah, four
okay.
hours, 4.5
All
hours.
right.
No traffic.
It's a big state.
Yeah, it is.
It's a big state.
Yeah.
Then we got Paul Shaves, and in Miami he's known as Paul Chavez.
Yes.
Yes.
Mr. Chavez.
At the hotel.
that's what they call him, yeah.
So it's awesome getting together here at the 2023 Diamond Conference, Diamonds Contractors Summit. And today we're going to talk about the inverter circuit.
Yes.
So all of our Mitsubishi systems run on an inverter circuit. So let's dive in and see if we can tackle this this topic and try to make it and everybody at home understand how the inverter circuit works without getting too technical.
Right.
And let's just start with the basic flow of electricity into the system. So we have incoming power coming into, and let's just keep it residential for now. We'll talk.
Sure.
We'll jump into
208,
commercial.
230.
But 208, 230, single phase power
Plus or
coming in.
minus 10%.
Yeah, coming into your breaker panel, from the breaker panel to the disconnect switch at the outdoor unit. Now you may have a buck boost transformer in there, maybe
Possibly.
to regulate the voltage. You may have some circuit protection in there or something. But basically 208, 230, single phase to our outdoor unit. And from there, we're going to go into our inverter circuit or power board.
Converter circuit.
Or converter circuit, yeah. And it's known as many different things, but basically it's comprised of 6 main sections. So we have the
let me just hold on, Steve. Let me just say something about inverters. Inverter compressors, right? It's a 3-phase compressor for all intents and purposes. But I just want to say from before we get into this, it's not just in heat pumps that you're seeing inverters. You're seeing inverter compressors in refrigerators, in appliances. You're seeing these inverter motors, whether they're fan motors or compressors,
appliances.
in small appliances now. And the technology is basically the same, right? And I think this is where you were going, Steve. We basically take AC power, we convert it to DC, we clean it up, and then we take and we simulate a 3-phase variable frequency, variable voltage, 3-phase power to a compressor or to a fan motor, sometimes both. And that's what we're going to talk about. Is we're going to simplify how that breaks down. I mean, you don't have to have an electronics degree.
Nope.
Being an electrical engineer to work on these things. So we're going to break that down. So
yeah. So it's 6 main. It's split up into 6 main sections: the input, the converter, the smoothing circuit, the inverter, the compressor, and the microcomputer.
Yeah.
All right. So we have our 208 feeding our power board, and it's a 60 hertz signal.
Yep.
208, 230, single phase.
AC power.
AC power. And from there, we're going to go into our diode stack.
Or rectifiers.
Exactly. And if you look at the symbol, the electrical schematic symbol for a diode, it looks just like a plumbing
Check
valve.
Absolutely.
So what does a check valve do?
One
Yeah,
allows
one way.
flow one way.
One way.
Yep.
Yeah.
Same
so,
thing the diode does for electricity.
Yeah.
It looks the same way.
So if we're taking alternating current and we're running it through a diode, what are we doing? What are we changing that
We're
AC
converting
voltage
it
to?
from AC to DC.
Yeah.
If you picture an AC sine wave, right? And this is the same thing that happens, by the way, same principle as flame rectification with a gas
Yes.
furnace flame sensor, right? You picture an AC sine wave that goes above and below the line, right? You're just knocking off that bottom part that goes below the line. That's all we're doing.
Right. So from there, because there's a lot of white noise and harmonics that are picked up in the incoming circuit, that can decrease efficiency.
Yes.
And it can make the electronics really noisy.
Yep.
Right. So we need to clean that. And we do that through, and again, called many things, a choke coil, noise filter,
What's filter
Yep.
coil? Yep.
right?
We call it a reactor.
Reactor.
Yeah.
Right. So what is that made up of?
Just a coil of wire.
Yeah. So when,
basic.
I get a lot of contractors that say, man, when I take the panels off of a ductless unit, Mitsubishi, whatever it is, I see all these coils, all these copper coils, and they intimidate me. Don't overthink it.
No,
It's just
voltage in, voltage out.
Yeah.
Yeah.
No resistance.
Yeah, there's no resistance, and that's the important thing. A lot of guys, when I was doing these classes and I'd show them the coil, I was going to say, well, it's a transformer, it's a coil, but it's just one coil, it's not two. And I always ask, what happens when you take a wire that has electrons flowing through it and you roll it up into a coil? You're creating a magnetic field. In this case, there's no resistance drop, so there's no voltage drop across this coil. That just cleans up the electrical noise, the harmonics. And, for people my age, if they remember before we had cable TV and there was an antenna up on the roof, Anytime
Or on a TV
yeah.
set.
Yeah.
Or on a TV set.
When I was a kid and my mother turned on the garbage disposal, the vacuum cleaner, the mixer, it didn't matter. Anything with a motor, I'd get those white lines across the TV screen.
Wait till I can remember. I can remember growing up with Grandpa.
Yes.
Wait until the commercial before you turn that on because we'd be watching the Red Sox.
I'll never forget our first TV. We actually picked it off the street. Somebody had thrown it away. This was
Fell off the back
in
of the
Miami.
truck?
No,
Oh, okay.
somebody was getting rid of it, and my dad and I would drive around town looking for furniture that was fairly okay. So we found this TV. Sure enough, it had the rabbit ears that we had to put the tin foil on the top to make it get the wave. Sure enough, when Mom would run a hair dryer or a vacuum cleaner, there went the lines on that TV.
Yeah. And that's electrical noise.
That is electrical noise.
In its simplest form.
So choke coils are in our everyday lives, and we don't even realize it. Choke coils are on our laptop chargers.
Yes.
They look like a small plastic barrel.
Yeah, if you see that little barrel at the on the cord, people always ask what that
It's
is.
a choke.
That's a noise. It's just a choke coil. It's just a noise filter.
Yeah,
That's all
and it's
it
going to
is.
keep us from getting any interference on the screen if we're plugged into a bad ground, possibly. We have a bad frequency coming in. We're going to clean that. And having those choke coils in there we call it a noise filter. It is what it is. It's going to quiet down that motor. And in this case, it's the compressor. And it could be a condenser fan motor. We'll talk about that.
Let's just talk about how to check it. So, that's the other thing. We don't have to go to a engineering school for solid state to figure out how to check this stuff. Basically, we just check what comes in for applied voltage and what comes out.
Yeah.
And that's all we're looking at. And it really at times can be that simple. What may be a little bit of a challenge is finding where your test lead points are. And that's what we have mylinkdrive.com for.
Yeah,
we'll show you.
there are schematics that show
Test
test
point
point
diagrams,
diagrams,
And
where to put the meter. It not only shows you where to put the meters, but it also tells you what you should expect for a reading.
Exactly.
Yes.
If it's working properly.
And part of that smoothing circuit is not just the choke or the reactor. When you pair the reactor with the capacitors,
Right.
that's what actually does the smoothing.
So I know this is an audio show, but I'm going to ask people, think to yourself of the sine wave symbol. The little hump comes up above the line, goes below the line, and above the line. We've gone into that diode stack and the converter circuit. We've knocked off the bottom part of that sine wave. So all you now is you're going to see those humps on the top of the sine wave. When you smooth it out and you get those capacitors, all those little gaps, those little valleys in that top part of that sine wave, you're now just basically
flattens.
filling those in.
It flattens the curve.
Right?
Yeah.
So basically, you're getting a high DC voltage at that point.
Right. And it's not a true DC signal because there's only one component made on Earth that can create and generate a true DC signal. And what is that?
The battery.
The battery.
Yeah.
Yeah, so that reactor, even though it's so simple, it's just a coil of wire wrapped around a core. It's creating magnetism, but it's doing a lot more than cleaning up noise. It's increasing efficiency of the system. It's raising our power factor,
Improving,
and
absolutely.
we're trying to get more usable energy and not so much wasted energy
Right.
at the inverter circuit.
And that's the thing. It's taking advantage of not only the usable voltage, but the applied voltage. Correct. So you take a meter and go to an outlet in your house and it's 120 volts. You're actually getting more than 120 volts
Right.
being
Well, your
fed there.
meter's only reading that. But
Your meter's only reading. Your meter's
But there's
only,
more.
only reading the effective voltage.
You
The
t-
applied voltage is higher than that.
You typically can multiply that by about 30%, just
Right.
a little under 30%. So if you're taking a voltage reading of 120, you really have somewhere around the area of 156 right now.
Right.
So, but the usable voltage, like you said, is at 0.707, or the power factor 0.707 is 120 volts, which is another thing too. Because I get students ask me all the time, how the heck can you come in with 208 and I end up with 300 volts DC?
It's
How does
because
that
it's
happen?
because you use the applied voltage, not just the effective voltage.
Correct.
So effective voltage is 208. Applied voltage is going to be, like you just said, 30% higher than that. You're not going to read that with your
No,
with your
but we can
meter.
read it on the DC side,
Right.
and then so you look at it now. Now you're looking at once again there is a different other ways you can determine what the actual DC voltage should be, and but you look at that and you've come in at 208, whatever, and all of a sudden you're reading 300 volts DC without a step up transformer, and that's because that smoothing coil, noise filter coil, multiple names, changes the
Right.
power factor.
Yeah.
It makes it more efficient.
Yes.
And believe it or not, that choke coil actually reduces motor temperature as well.
Yes.
So it's doing
By
so much
improving the
than
power
more.
factor.
Yeah. Yeah.
Yep.
And I just want to back up a second because you just touched on something, Roland, where you said, well, we have 300 volts DC. There is math that we can use to figure out.
We use it, yeah.
Yeah. So whatever your incoming AC voltage is, multiply that by 1.41, and that will give you your true DC voltage, what you're supposed to be getting. Now, we say in class, you should get in a ballpark
Right.
of about 300 volts.
But the thing is that where I have like a dead 208, 209 all the time in my class, and I tell people, give it a few minutes. Don't jump on it the minute you plug it in, but give it a few minutes, especially in the taste mode. It is common that we are maybe 2 volts DC difference, and that's it. It's dead. It's dead on all the
Yeah,
time.
yeah.
So and the same with the 3-phase as well with the City Multi. Different story, but the same thing works on that too.
Yeah, so if you're looking at about 208 coming in, you're looking at about 298 volts DC. If you're in a 220, 230 range, you're looking at maybe 310, 320.
Well, this
DC
actually
volts.
goes back to a conversation earlier because I'm in Florida. I got a place called the Villages. Villages runs about 247, 252. It always runs highest voltage. And I remember my class one time asking, okay, what's your voltage read? It's 300 volts DC. Good. And I had half the class goes, yeah, that's about right. And that's what it is in my class too. I had the other half of the class going, no way, man, that's bad because they're from the Village area. And they're always looking at like 349.
Wow.
350. Well, because again, how do I find out what my DC voltage? I take actual AC voltage. They're looking at 247, right? Multiply it by the factor, which stays the same, 1.412.
I think it's
1.41.
1.414.
And that comes out to about 349.
Wow.
And that's what they're used to seeing. And I said, you guys just did teaching for me. Perfect. Thank you.
Yeah. Okay, and by the way, this is what we're talking about, the inverter circuit. This is across the board for all our equipment. Residential, commercial, P-Series, Y-Series, R2, it doesn't matter. Sometimes we do it on one board, sometimes it's 2 or 3 or more.
Right.
But it's all the same. What we're talking about is the same principle across the board for everything.
It's in the condensing units, in the wall mount units, in our ducted system.
Yeah.
You know, they're not just in one unit, you know, for the most part.
Yeah, and sometimes you may see this inverter circuit inside a motor. You don't see it. You can't test it.
Exactly.
You just know the power going in. And sometimes it happens on a board and you're feeding the 3-phase to the motor. So there are some changes. But just to recap, we got 208, 230 single phase AC. This can also be 3-phase. It can also be higher voltages, but it's AC power, regardless of what that voltage is. AC power coming in, goes through the diode stacks, only allows electrons to flow in one direction, knock off the bottom part of the sine wave, goes through a smoothing circuit, does all those things we just said. We've got the capacitors, and capacitors charge and discharge, charge and discharge. So if you picture that sine wave, you're filling in those peaks and valleys on the top part of the sine wave. What's the next part of the circuit?
The inverter.
And what happens there?
We take that DC converted AC, and then we invert it into a simulated 3-phase AC balanced signal going to the compressor.
And it goes through these IGBTs, which are insulated gate bipolar transistors.
Or triacs.
Or triacs, whatever you want to call them. And I like to say that those are just switches that open and close a bazillion times a second.
Yeah.
I've heard 25,000 times per second.
Let's go back to the IGBTs.
Insulated gate bipolar transistors, or as Juan said, triacs. Right?
And here's something interesting. And there are 6. There are 6 of these switches, and I like to think of them as someone used this analogy one day with me, and it kind of made sense to me. Think of all 6 of those switches being little revolving doors.
That's me. I said that.
Okay.
That was me.
All right, chill out, Roland, man.
Just chill out, man.
It was me.
It sounds like you need a Cubano.
If you think about every time they make one revolution, they open and send voltage through. But there's 6 of those switches. So every time 2 of those switches send voltage to that motor, it turns the motor 120 degrees. Another 2 switches close and send voltage to that motor and turn it another 120 degrees. So think of that, but it's happening at
a bazillion times a second.
Bazillion?
Bazillion.
I don't know if that's,
Can
I don't know
you
if that's
count
completely
starting
accurate.
at
We'll
one?
go with that, Paul. But it is happening quite quickly. But we're manipulating the speed in which that compressor can
Yes.
run. So we can now manipulate that frequency. So we were coming in at 60 hertz, which is standard in the United States. And now we can run that motor from 0 to 120, 130 hertz on some units.
Yep.
So now we have a wide range, and we can start that compressor off at a slow speed and ramp that up 5 hertz, 10 hertz, 15 hertz, all the way up to 120, 130 hertz.
So now coming out of this inverter board, 3 wires that we call them U, V, and W.
Yep.
And those 3 wires are going to a motor. And for all intents and purposes, as far as anybody is concerned, it's a 3-phase motor.
Yes.
And you treat it just like a 3-phase motor when you're looking at the windings, when you're looking at the voltage, when you're looking at resistance or whatever. As far as you're concerned, it's a 3-phase motor. And this is where I think it's the magic happens. It's not really 3-phase AC power because it's been DC.
There's DC
AC
there.
converted DC. So it's a simulated.
Yes.
Yeah, and it has every characteristic of DC voltage.
It does, but
It likes to arc.
Yes.
motor can't tell the difference.
And this is why I always tell students in class, and I always ask them, how many of you have gone to, a PSC compressor and taken a voltage reading at the terminals? Some guys will raise their hand, C and S and R, they've taken their voltage readings. I said, don't ever do that on an inverter compressor because it's DC voltage, it's a high DC voltage, and it's going to arc. Your meter leads are going to be so close together. You can't keep them far enough apart. Right. And I've seen it happen where guys just don't listen, and there's a bright flash. It's a bang. It's
pop.
loud, and something's going to get fried. It could be your meter. It could be your board.
Hopefully, it's your meter.
Hopefully, it's the meter. That's the best thing. That's the cheapest thing that can get fried. But so you never, ever take a voltage reading at the compressor terminals. Take the voltage readings at the board at UV and W. They're far enough apart where they won't arc.
Yeah, especially residential equipment because the compressors are smaller, terminal spacing smaller.
And it's tight.
Yeah,
It's tight.
So larger compressors with the VRF, you have a little more leeway there. But
I still wouldn't do it.
yeah, and at the same time, it's easier
It is.
to go back to the board and find your lugs, UV and W.
It's always easier.
Yeah, and check your balance voltage that way.
And let's just back up on that too. So let's just take a look at this. So here's your amp meter. So now you have your amp meter on your meter. You have the opportunity to put it on UV and W. But even at that, it's not 100% accurate.
No, it's a
Because
different frequency.
It's a different frequency. So you really look at it, it's like 1 out of 108 chances that you're going to be at 60 hertz. So we have other tools
Yes.
that you can use.
Yeah, the
to
smart
check the amp.
multi-unit allows you, through DIP switches, SW1, you can look at the LED screen and look at target frequency versus actual frequency. And it'll show you where that compressor is. So that compressor, and let's just take a smart multi-system, basic runtime of a smart multi-system. For the first 4 minutes, that compressor is just sitting idle at a certain frequency. And then after that 4 minutes, it's going to ramp up.
Right.
So first 15 minutes, I'm not checking pressures. I'm not checking temperatures. I'm
Chill
just letting
out.
that, letting that compressor run up, get up to speed. All right. But basically, I get this question all the time in classes: what should the voltage be at my compressor?
Yes.
It doesn't matter.
It does not matter.
Who knows?
As long as it's balanced,
Absolutely.
nobody cares what it is.
Plus or
It's
minus
60
10%.
volts, 120 volts. That's what guys think. Well, there should be, a 208. No,
No, we don't know what it is.
we don't care what it is. As long as you measure the same voltage from U to V, in V to W, in W to U. I think I get that right.
Yeah, you did.
Okay, because I have to
it's
kick
good.
off my
It's tough
shoes.
to do. Tough to
Okay,
do.
I know.
Especially with the U and V.
So
kind of
just
look.
as an example,
And
across
W looks like 2 V's.
Yeah, it does.
across U and V, you have 110 volts. Across U and W, you got 112. Across V and W, you got 109.
That's still within 10%.
It's balanced voltage.
But
I've never
But
seen
wait a minute. Let's just be clear. So you still need to be unit specific.
Look
When
up the
you
manual.
Look at the manual because it's not always 10%. Some are 4.
I've seen 10. I've seen 20%.
Yeah.
Where there's a lot of leeway in
just,
there.
Once again, just unit specific.
I've taken my share of those readings, and I've never seen it more than
listen,
a
a
couple
volt,
of volts.
maybe.
Yeah, maybe 2.
Yeah, maybe. I know our examples in our PowerPoint presentation does show you the full scope of that 10%, but I think that when you look at even the diagram we have on our PowerPoint, I think it's 0.8 of a volt.
Yeah.
So let's talk about a traditional three-phase compressor non-inverter system. If we take any one of those legs of power, T1, T2, T3 on the compressor, and we swap it, what happens?
Well, I don't know if I want to do that.
Well, it's
on a
okay.
regular
On a
motor,
non-inverter
on a regular-
system, what
A
happens?
non-inverter system.
It runs backwards.
It can run,
Right.
absolutely.
Yeah, that doesn't work with an inverter compressor
Right.
or motor. It doesn't work.
And I used to install a lot of rooftop units, and
Exactly.
the electrician would come in, wire it up, and he would come up to us and say, hey, you want to bump it?
No.
And that would mean he's going to check rotation. He'd give it a quick flip the disconnect, blow is running backwards. All right, shut it back down. Let's swap legs. Well, guess what? UV and W is UV and W. We'd never swap that. You're not going to get the compressor to run backwards. You're actually going to either cause damage or it's going to go off on overcurrent. Now, what is actually shutting the system down on overcurrent? There's something called a microcomputer.
Right.
And that's built into the circuitry. It's built into the circuit board. It's there to measure amperage across U and W.
Right.
So if that amperage goes up for any reason, compressor's locked up, maybe it's pumping liquid, God forbid, right? Or UV and W are crossed.
I'm going to tell you,
Right.
my first site visit after joining Mitsubishi was up in Minnesota, and it was cold. And I want to tell you just how fast those things react. We went to start up a system outside, and it was a City Multi R2 system. And me and Jerry Flynn, one of the area service managers up there, we were outside, and we didn't know that they just turned on the power. This was October. It was pretty cold up there.
No,
So that compressor was cold. So what's sitting in the compressor?
Liquid.
It's a liquid, right? And is the compressor going to start when it's covered in liquid and it's cold like that? The oil's congealed. It's not going to start. But we were outside, and we didn't know this until Jerry looked on maintenance tool. But that thing tried to start, and it errored out on that high current, and we never saw anything. We never noticed it sitting there. We had an amp probe on the legs of the power coming in. It never did anything.
No.
Those things reacted so fast that we couldn't even tell it tried to start. So if it's not starting, and you get that fault, the high current fault, but I didn't see anything start. Start looking. Why? Because those things are fast acting.
And then that goes back to doing the resistance test, because the resistance test is going to test the integrity of the windings. So if they pass by having 3 equal ohm readings, then the failure of the compressor has got to be mechanical.
Right.
Because the lac rotor, like you just said, you're not going to be able to pick it up with a regular amp probe.
No.
Because the inverter is so quickly to detect it, it's going to shut it down.
Yeah, well, in this case, it was asking some questions. And there's a whole nother story here. It ended up being, I don't want to go down this rabbit hole, but it ended up being overcharged by 56 pounds.
No doubt.
So that didn't help.
Did they have a sight glass on that system?
Yeah.
Stop that. Cut that out.
Let's go back to the beginning and what we talked about. We have 208 single phase.
We were talking about Cubanos in the beginning.
Yeah. Oh, you want to go very beginning.
The Cubano comes in at 208. No. We have 208 single phase coming in. We run it through some diodes and change it over to DC voltage. We clean up that DC voltage.
But hold on, Steve. That incoming voltage could also be 3-phase.
Correct.
Could also be
208,
three-phase,
could be
yeah.
460.
Yep, from VRF. From
Right.
yeah.
So because we got 3-phase equipment up there, so it really doesn't matter if it's single phase or 3-phase. The same thing happens. I'm sorry to interrupt. I just wanted to get that out there.
Yeah,
Diode
absolutely.
stack.
Diode stack. We change over to DC voltage. We clean it through a reactor, through a choke coil, whatever. And I just want to point out too that reactor is not only cleaning the DC side of the voltage. In some systems, we have reactors that clean the AC side.
Correct.
But it's about keeping these units. And when we say whisper quiet, our units are whisper quiet. They're not really whisper quiet, but they're pretty darn quiet.
Yeah.
And if we didn't do that, if we didn't run them through our reactors, through our smoothing capacitors, we would hear a lot of motor noise.
Yes.
And then through our IGBTs, insulated gate bipolar transistors, they're just switches, right? There's 6 of them. And we're taking that and taking that DC voltage and changing it over to a simulated AC voltage to the compressor. And the common relationship.
Variable frequency, variable voltage.
Yeah.
Correct.
And the
Balanced.
common relationship across UV and W is that the voltage is balanced.
Yep.
We don't care what it is. And again, I've just tested this before. I've taken different brand multimeters and checked that voltage coming out of the inverter circuit. Every meter interprets that square voltage differently. It really is a square voltage at that point. The frequency, that sine wave is different.
Steve, how fast do those IGBTs open and close?
A bazillion times per second.
Per second.
Fractions of a nano.
That's not 100% true, but we'll go with it.
All right.
It sounds good.
I just want to point something else out. We also do the same thing with condenser fan motors.
Yes.
Not on all systems, but most of our commercial units and a couple of residential units, we actually have a UV and W controlling, sending balanced voltage to our condenser fan motors.
Yes.
Most of our other indoor fan motors, believe it or not, inside of the motor, molded in, is an inverter circuit.
Right.
It's just all built in solid state into that motor.
And in those motors, you've got 300 volts DC going into them, being inverted into a balanced simulated AC three-phase signal going into the windings.
Right. So we're not going to be replacing IGBTs. We're not going to be replacing some smoothing capacitors because they're part of the circuit board. So we're going to be checking voltage in, voltage out.
And
Right.
that's it.
Yeah.
And we're replacing that circuit board and trying to find that component that's malfunctioned. It may be different malfunctions, right? We could have a bad power board because of a malfunctioning compressor.
Yes.
We could have a malfunctioning compressor because of a bad power board.
Yep.
Right? So we've talked about this at previous episodes before. But I think that just about wraps it up with
That's it.
the basic
That's
inverter
a good
circuit.
one.
And I hope it helps everybody out there. If you need more information, go to mylinkdrive.com, pull up that unit-specific service manual.
Absolutely.
Yeah. And if you have any questions, email us. If you have any topics you want to hear, let us know. We'd love to hear from
Where
you.
would they email us if they were to email
METUS Tech Show at hvac.mea.com. And Steve, don't we have a Facebook page and a YouTube page?
Yeah, we also have a METUS Tech Show Facebook page, and we have a METUS Tech Show YouTube channel.
Yeah. Okay, so look for
Awesome.
those. And we got some other things on there. We got, what are those things called? Tech tips. There was a couple of tech tip videos
Tech
on
tip
there.
videos, and we have a whole pile of tech tip videos that we just recorded, which will be uploaded soon to my link drive.
Yeah, and we got our
And-
podcasts are on there. If you don't want to listen to them in the car, if you want to hear them again, play them for your family at night.
Our
To
training
put them to
team,
sleep.
Yeah.
our training team. I'd like to add too. Our training team is working really hard on something called Tech Links. They're just PDF files, quick reference guides on how to diagnose compressors, how to diagnose thermistors, how to diagnose LEVs. Those will be all going onto my link drive very soon,
Awesome.
and so stay tuned for that.
And if you want to find training at one of our training centers, the METUS training centers, go to MitsubishiComfort.com. Right, look for pros and look for the training there and sign up for that. Also, check with your local distributor, whoever you buy your equipment from. They probably have training, and there's almost 100 training centers out there on a distributor level. So no excuse for not going to training.
Exactly.
And training's important for everybody. I don't care if you've been doing this for a year or 40 years. You need training. All right. Thank you, guys. Thank you,
right,
everyone,
yeah.
for
All
listening.
right.
We'll see you on the next
Enjoy.
one.
Adios.
All right.
All right.
Hasta la vista.
All right. So when are we going to get some Cubanos now?
I say tomorrow.
Really?
Yes.
All right. Before the thing starts?
Yes.
I'd rather go there for lunch than eat the lunch. No, hotel food's good.
I'm
I'd rather-
sure there's a Cubano place within blocks of here.
Okay.
They're all over Miami.
All right.
Yeah. What about
We'll let you-
chicharrones? I'm kind of
Chicharrones?
looking for something like
I'll
that.
look and see. I'll look and see. There's another place. I don't know if they may have a branch up here on this end of Miami, but I'll check it out.
All right. Hold on, Juan. I have a mission for you tomorrow morning.
Yes, sir.
I need Cuban coffee.
Ooh,
Okay.
We're going to find Cuban coffee.
Okay. And
good
pastelitos.
idea.
Pastelitos?
Yeah.
Okay.
Guava pastries.
I know. Those are so good.
Yes.
All right.
Okay.
I'm hungry again.
I'll call my buddy to see if he can Google something for me.
I've gone almost an hour without eating, so let's go. All right. Bye, guys.
Bye.